So fall semester Earth Systems is primarily about the weather. And what do you think of first when you think about the weather? Well, you think about the temperature. How hot is it going to be today? And that's what we're going to start with first is an examination of temperatures.
So let's do a real simple short demonstration to show for us what temperature is. If you take your hands and you put your hands together and you start rubbing them back and forth, you feel a sensation. It gets hotter. That's temperature, because in simplest terms, we describe temperature as being how hot or cold it is. And you know, if you rub your hands back and forth, your hands get hotter. That's what temperature is. Now, think about if your hands aren't touching and I rub my hands back and forth, I don't get that same sensation that I call temperature. The difference is my hands aren't touching. If two things aren't touching but they're still moving, there is no friction between them. And that's what causes temperature. That's what temperature is. Temperature is a measure of the amount of friction between two moving objects. Well, how does friction affect temperature? You know that the faster you rub your hands together, the more friction you're going to have and the higher the temperatures. And if I move my hands slowly, I have less friction and hence I have lower temperatures. So temperatures are all about friction. And the definition of what temperature is that temperature is a measure of the amount of friction between moving objects. So this is a thermometer, and you know what a thermometer measures. It measures temperature. But we just described that temperature is friction. Well, I'm not rubbing my hands together here. I don't have the thermometer between my fingers. What friction does a thermometer measure? Well, this thermometer is measuring the air temperature in the room. The question becomes, what's rubbing up against the thermometer that's creating some friction that the thermometer then measures for me? The answer is air. And if we think about these two little ping pong balls being air molecules floating around the room, every now and again those air molecules come by and they hit the thermometer. Every time they hit the thermometer, that creates a little bit of friction. And the amount of hitting or rubbing or friction caused by the air that is hitting this thermometer is the measure of temperature. That's what temperature is. It's a measure of how much friction you have between objects, whether it's the friction between water molecules in a cup of water or in a swimming pool, or more commonly, the amount of friction from the air that is hitting each other and the thermometer in the room. So consider this container right here. It represents a sample of air and has a certain temperature because the air inside of it is moving around and hitting each other and hitting the sides of the container. Well, we'll use our ping pong balls to model those molecules of air that are bouncing around. And if I move the container, you can see those molecules move around. They hit each other a little bit. They cause a little bit of friction, and the amount of friction that we have between those ping pong balls is what temperature is. The question becomes, how does temperature change? How does temperature go up and then it goes down? Well, it's all about the number of collisions. Can I make these things hit each other more often? If I make the ping pong balls move more, they're going to hit each other more often, and the more often they hit each other, they're going to have more friction and temperature will go up. What about right now? They're not moving much at all. If I just bounce it really easy, they don't hit each other very much. That means there's going to be less friction and we're going to have a lot lower temperature. So remember that the temperature is dependent upon how much air particles are moving, because the more they move, the more they hit each other. The more they hit each other, the more friction you have, and hence the higher the temperature.
But here's the trick with that changing speed. It doesn't happen on your own. It takes something to make that change happen. You just can't go faster on your own. Any kind of change requires an input of energy. To make things happen, you have to use energy. That's what energy is. It's an ability to cause change. And for us in this particular unit, we're going to talk about that change in temperature. It takes energy to make a change in temperature. So here's how it goes. You give energy to something, it makes it move faster, which causes more friction, which makes the temperature go up. But the opposite is also true. If you take energy from something, it's going to move slower, which is going to be less friction, which is going to make temperature go down. But energy is not free. You know this. The energy that we use in our daily lives, in our cars, for our electricity, whatever, energy is not free. It's got to come from somewhere. And that's the law of conservation of energy. It cannot be created or destroyed, but we can transfer it from one thing to another. And that leads us into what is heat. Heat is energy that goes from one thing to another. That's that energy exchange.
So heat is energy that is transferred from one thing to another. And we know that energy is going to change something's temperature. Well, think about heat. Right now I'm sitting in a hot car and I can feel heat from the sun beating down on my car, and it's making my temperature go up. That's what heat does, because heat is energy coming from the sun into the car and to me. And all that extra energy makes my particles move faster, which creates more friction, which makes the temperature rise. Now, we can kind of help remember this concept of heat if we think about what we have in our car, and that is this device here. This is a heater. And what a heater does is it transfers energy. It takes energy from the engine, which is out there, and brings it through the vent to me. So think about what a heater does. It makes you warm. It brings you energy to raise your temperature. So that will help you remember that heat is energy that comes from one thing to another. So here it is, a nice, hot, sunny, summertime day. So we have a very high temperature. So all the stuff is moving really, really fast, creating a lot of friction, which raises the temperature. Well, all of that takes energy. And energy can't be created or destroyed. It's got to come from somewhere. So the question should be, where did all of the energy come from to make it so hot out here today? Well, the answer is up there in the sky. All of our energy on the planet comes from the sun, because energy cannot be created or destroyed. It's got to come from somewhere. And for the most part, all energy on the earth that determines our temperatures comes from the sun.
Now, that energy transfer, that heat, is only done by one of three methods. One is conduction, which is touching. Two, which is convection, that is when water or air is moving the energy around. Or finally, radiation, which is the transfer of energy by waves through open space.
So the first method of heat transfer is called conduction. Conduction is when you are physically touching whatever is releasing the energy. In this case, it's the stove. And you know how a stove works. It doesn't work very well unless the pot is actually touching the burner. That's an example of conduction. If the pot isn't touching the burner, the heat will not be transferred. So once again, conduction is the transfer of heat or energy when two things are directly touching one another. So this right here is a furnace or a heater in your house, and it's usually located in a closet or in a basement or in the attic. And in the case of this one, it's a gas furnace, so it actually burns natural gas and it releases energy, which can then be used to change your temperature. Well, let's talk about how do you raise your temperature using a furnace in your house. You don't have to come down here and touch this furnace in order to get hot and have your temperature raised. So the question becomes, how is the energy transferred from this furnace to you and other places in the house? So here's how the heat comes to you in other parts of the house. You'll have an air vent, and you push air over the heater in the basement or in the attic, and it gets that air hot. Well, then the air comes through the house and out of this vent, and that hot air brings heat to you, and raises your temperature. So a heater in your house is an example of heat transfer by convection, because it's air that is moving the heat from the furnace to where you are. It's not conduction, because you don't have to go and touch the furnace in order to get the energy that you need to raise your temperature. So there's the sun in the sky, the source of all of our energy that causes our temperatures here on the planet. The question becomes, how does that energy get from there down to here? Well, there's three ways in which the energy from the sun can get here. Conduction. Well, nobody reaches up there and touches the sun, so it can't be conduction. Convection is when we have water or air that brings the energy to us. Up there in the sky is the vacuum of space. There is no water and there is no air between the sun and the earth, so that can't be how energy is transferred. The only other way is radiation, which is the transfer of energy by waves, which can go through open space, which is exactly how energy gets from the sun down to us, the process known as radiation. So basically everything has temperature, and something's temperature is a function of how much are its particles moving, and a particle's ability to move depends upon the energy it gets. And on the earth, pretty much all energy comes from the sun. So consider the parking lot back here behind me and the concrete. It's sitting out in the sun, it's getting energy from the sun, so the molecules here in the concrete are actually wiggling back and forth a little bit, and they wiggle more when they're out in the sunlight. Well, if they wiggle back and forth more, there's going to be more friction, and hence they're going to have a higher temperature. So if I take the temperature, right now it says 101 degrees on this concrete sitting right here out in the sun. Now, just a few feet away from that same concrete, it only registers 82 degrees. Well, it's the same concrete and we're in the same location. There's the same amount of concrete. The difference is the amount of energy that is being received by this concrete here. It's in the shade. The sun hasn't hit this part of the concrete yet, so it hasn't got as much energy from the sunlight. So its particles are wiggling a little bit slower than the concrete that was over there and out in the sunlight. So remember that a thing's temperature is determined by the amount of energy it gets specifically from the sunlight. So if we lessen the amount of energy coming from the sun, you're going to have a lower temperature. This is why it's always cooler in the shade. This is why you would use an umbrella on a hot day and not just on a rainy day. Anything that blocks some of the sun's energy means you're going to receive less energy. The less energy you receive, the slower your particles are going to wiggle, whether it's the air under your umbrella or your body's actual particles. So anything that can block energy from the sun will result in a lower temperature, whether it's an umbrella or standing underneath a tree or a cloud in the sky that blocks the sun. The temperature is going to go down because there's less energy. Less energy means less motion. Less motion means lower friction, which that's all temperature is a measure of the amount of friction. So as it turns out, there's more than just how fast the stuff is moving that will affect how high or low the temperature is. And just to recap, you understand that these air molecules bouncing around in this container are going to hit each other. The more they hit each other, the greater the friction and the higher the temperature. Right now, I've only got about 3 ping pong balls in there. And they bounce around, and they hit each other, and they cause collisions. Well, how could I make there be more collisions? What if there were more air in the container? Well, now, even if they're moving at the same speed, I've got so much more stuff in there, I have a lot more collisions. And more collisions means a greater amount of friction, and a greater amount of friction means a higher temperature. So the second big factor that determines the temperature is how much stuff is moving around and hitting each other. How much air is there? The more air you have, the more collisions there are going to be, and hence the higher the temperature.
So where is there more or less air bouncing around and hitting each other? As it turns out, there's a lot less air as you go up from the ground, or as you go higher in elevation. The further away you get from sea level, there's less air. As you get down closer to sea level, lower in elevation, there's a lot more air. Now the question is why? The explanation is gravity works. So gravity basically pulls air down. So you always wind up with more air near the ground and less air the higher up you go. You can see that here in this airplane. I was at 20,000 feet and I checked the outside temperature and it was negative 24. That's really cold because you're really high up where there's really less air bouncing around, less friction, hence a lower temperature. But then the plane went up even higher, went to 30,000 feet, and the temperature dropped to 54 because there's even less air up there and less friction, less stuff to hit around, and be a lower temperature. This is why outer space, it's impossibly cold, because there is no air bouncing around, rubbing up against one another to have a temperature. You can see it a lot in things like this. The mountain, you can tell right about there is the line where it is 32 degrees. And that lower than that, it must be warmer, because above 32 degrees, that high enough in elevation, it's cold enough for it to be snow. And lower than that, it ends up being rain because it's warmer lower to the ground. This is the reason why a lot of people like vacation homes up in the mountains, traditionally especially. Consider a place like New York. And notice this is an elevation map, so that I have my higher elevations here and my lower elevations are the darker colors. Well, in the days before air conditioning, in the month of July, it might get really, really hot. In New York City, it might be 75 to 77, and that's an average July temperature. And it can certainly get a lot hotter than that. Well, when it got hot in the cities, especially if you were somebody that had money, you purchased a second house. The kids were out of school, maybe work was slowing down, and you would go to the mountains where the temperatures were only 62 to 65 because you were higher up in elevation. So the higher you go in elevation, the cooler your temperature is going to be, because there's less air up there moving around and hence less friction, lower temperature.
So here I am on the upslope of the Mauna Kea volcano in Hawaii, and I'm at an elevation of about 9,000 feet, so there's not a whole lot of air up here moving around. And you can note from my thermometer the air temperature is about 64 degrees. Well, I'm going to get in the car and I'm going to drive right back down to sea level where there's a lot more air rubbing up against me, and I'm going to note what the difference is in this thermometer on my way down and once I'm down at the bottom. Now let's take a look at the difference in the temperatures from up there at 9,000 feet to down here now at sea level. Because there's so much more air down here than there was up there, there's a lot more friction because there's a lot more air rubbing back and forth against each other. And you can see how high the temperature has gone up, almost 20 degrees, and I've only driven about 30 minutes away from where I was. The difference is there's more air here at sea level, so there's more stuff rubbing together, hence more friction and higher temperature than at the higher elevations where there is less air moving around, making less friction and a lower temperature.
So that's the end of our presentation about introductions to temperatures. Here's an idea of the key vocabulary that you should now be able to define, and some concepts that you should now understand after watching this presentation. After you understand these concepts and you've completed your notes, please see me to take a notes check on this information.